Okay, so the do now is for each of the above, write r, which is a length, in terms of f of x and the axis of rotation. In this case, for number one, the axis of rotation is y equal to 1. So I'm asking for what is r? So what is the length of this r? What is the length of that r? So what is the length of that r in terms of f of x and the axis of rotation? Okay, so the answer to this one is actually f of x. And then f of x, in reality, if you zoom in, is going to be this length right here. So it's going to be this part. Okay, so, and let me actually write it down so that you guys understand where I'm coming from. So f of x is the length from the x-axis to a given point. Okay, so f of x is the x-axis is right here, and then this is the given point, right? And why is it f of x, you may ask? Because any point has x comma y, right? So any point can be written as x comma y, where y is the height, which will be the length. So f of x is the length from the x-axis to a given point, and then the important one is radius. So radius, or r, is the length from the axis of rotation, okay? Axis of rotation to a given point. So r is the length from the axis of rotation to a given point, which in this case, for the example of the do now, is going to be from y equal to 1 to the point x comma y. So this would be f of x minus 1. Why? Because f of x is the blue length, and we're basically subtracting 1, which will be this distance, right? This is 1. And let's actually use green. So this is 1. So we do f of x minus 1. So now try the second one. Try the second one. What is number 2? What is number 2? What is r? Come on, guys. Everybody, please try it, because I really need at least half of you to understand this before we actually move it on to the actual rotation. So even if you're not sure, just give a guess. What is r? Remember, if it's touching this point, then this must be x comma y, which means that this is f of x. Or in other words, the distance from the x-axis to the point. And then they're giving you that y is equal to -2. So that means that the distance from here to here is what? What's the distance from the x-axis to the axis of rotation? Well, that's going to be 2, right? And now what is r? R is equal to f of x plus 2, okay? Okay, before I go ahead and move on to the actual problems, notice that here they gave me -2 for my y. The truth is that I don't really expect to use that as much. What I am expecting to do is to find distance, to find length, and to apply it properly. Sometimes, like in the case of problem number 1, I will be subtracting that length. So I'll be using f of x minus, because my r is smaller than my f of x. When you have a larger r, so in other words, when r is bigger than your f of x, then you're adding the extra length that you have. So depending on the different example that we're using or different problem that we're using, we're adding or subtracting, depending on which one makes sense. So now let's look at a specific problem. So everybody, please go to Schoology and open problem number 1 on assignment A5. Open problem number 1 on assignment A5. Or you can just copy it down from what you see on your screen. This is problem number 1. Copy this down. I'll give you 30 seconds. If you already copied it down, then start graphing it. Okay, so problem number 1, we start off with y equal to x squared plus 1. So x squared plus 1 is going to be an open up parabola, right? Where it's shifted up 1. So I go ahead and move 1 to the right, 1 up, move 2 to the right. That means I go 4 up. So 1, 2, 3, 4. So essentially it has this shape. So this is the shape of the parabola. Now I also have y equal to 1. Y equal to 1 is here. And my second line is x equal to 2. And x equal to 2 is here. So this is my x equal to 2. Okay. This is where things get different. Notice that we usually, before, we used to go ahead and rotate on either the x or the y axis. We are no longer going to do that, or actually we're going to have a combination of different ones. In this case, we're going to rotate around a shifted axis, which in this case happens to be y equal to 1. So y equal to 1 is going to be my axis of rotation. Okay. Now, notice that y equal to 1 is parallel to what? Y equal to 1 is parallel to the x or the y axis. Tell me in the chat. y equal to 1 is parallel to which axis? The x-axis. So that means that my axis of rotation is going to be the x-axis, okay? So that means that my integral is going to be stacked on the x, basically. So my integral that I'll be using for this problem is going to be ax dx. Because these problems are starting to become harder, what I suggest you do if you want to go ahead and look at a sample disk is to graph it on a separate graph. However, for this assignment, you are not required to do so, but it is something that I do encourage you to try. So in this case, because this is the first problem, I will go ahead and graph it, and I'll ask you to do the same. So on a separate X and Y, please graph the graph and make a sample disk. Okay, so I'm looking at these coordinates. Oh, it's actually going to be here. This is 4, 3, 2. Oh, no, 5, right? This is 5, 4, 3, 2, 1. And this is 1, 2, 3, 4. This is going to be my axis of rotation. So if that's my axis of rotation, and that looks a little bit off, let's make it nicer. Okay. And I also have this one right here. What I have to do is first reflect it, right? So 4 up, so I go 4 down. So 1, 2, 3, 4. And then 1, 1, so that's over here. And my sample disk, you can put it anywhere, but in this case, I'm going to go ahead and make it here. Okay, so that's my disk. And on top, I have my rotated axis, right? So I'm trying to find basically the R for this disk. So the R for this disk. Okay, so copy this down. Once you have it copied down, if you have an idea of what R is, then let me know. So what do you think R is equal to? Give it to me in terms of f of x. So give it to me in terms of f of x. Again, give me the answer in terms of f of x. So f of x plus 2, f of x plus 1, f of x minus 1, f of x minus 2. What is R? Okay, so I gave you guys some time. The answer to this is actually f of x minus 1. And the reason for this is because if I go ahead and think about it the way that I was thinking about it on the do now, let me go ahead and erase this part. basically what's going on then is I have this length here, and then I have this one here. And what do I know? Well, I know that this is f of x, right? Because that's the same length as this one. F of x, remember, is the distance from the x-axis to the point. So the distance from the x-axis to the point is f of x. And because this is parallel, so then this one has to be the same as this one. So this blue has to be the same as this blue. And then I know that the distance from here to here is always equal to 1. It doesn't matter if I make it here, if I make it there, if I make it here. It doesn't matter. The truth is that I could have chosen this to be here, and it's still going to be equal to 1. So then the answer is f of x minus 1. Okay? So this is f of x minus 1. Now, you don't have to write all of that, but that's the thinking process behind it. So the thinking process behind that is this. So you have something like this, and the answer is f of x minus 1. Why? Because the distance from here to here is 1. So you subtract it. It makes sense to subtract. Is there anyone who has any questions? Very good question. Why didn't we move the left-hand side of the graph onto the second graph? We don't move this one because this one's not bounded. It doesn't tell us when to stop. This graph goes on to infinity. So we cannot go ahead and do that. We have to go ahead and only rotate the one that is bounded, which happens to be this one, only this area. How do we know when it's either positive or negative? What do you mean? Are you talking about the 1? You do it based on whether the radius, so this is the x-axis. From the x-axis to the point, that's f of x. Is the radius smaller than f of x or larger than f of x? Is the radius, which the radius is in red, is the radius smaller than f of x or larger than f of x? Think about it. F of x is larger because f of x is from the x-axis to the function. So because f of x is larger and I'm trying to find r, then I have to subtract this green part. So that's why it's minus. It's minus because it makes logical sense. It has to be, r has to be smaller than f of x. So I have to subtract something from f of x. That's the reason why. Any other question? Again, this part is what I think really clarifies it. So if you want, I'll move it over here. So f of x is the length from the x-axis to a given point, and the radius is the length from the axis of rotation to the given point. All right, so I don't see any more questions, so let's go on to number 8. And let me go ahead. And now those of you who are in AP Calc, you have to do 1 through 10. So if you wish, you may go ahead and mute me because I know that you guys already went over this. So do numbers 1 through 10 and work on chapter 13. And chapter 13 is due Sunday. Okay? So that's for AP. Chapter 12, thank you for reminding me. So chapter 12 was due this Sunday, but I didn't make an assignment for you to submit it. So I'm planning on having you submit both of them by this Sunday on the same assignment. Okay, so let's go ahead and look at number 8. Hopefully you guys copied it down. Let's go ahead and graph it. Always what I recommend is to visualize it in your head. In this case, this is going to be an upside down parabola, and it's going to be shifted up, right? So something like that. So that's how it should look. So let's go ahead and graph it. It's going to go up to 2. And because it's an upside down, you go 1 to the side and 1 down. And then you go 2 to the side. So 1, 2, and then you go down 4. So if you go down 4, then it should be here at -2. And my new parabola looks something like this. Quite nice, may I say. Now, good question. Why did you stop there? The truth is because I did this one on the morning, but you don't really need to stop there. It goes on forever. And then you have y equal to -2. Well, y equal to -2, that's going to be here. And my axis of rotation is y equal to -2 as well. Okay. Uh-oh, battery low. Let me see. So think about what area I need to rotate while I go ahead and connect my tablet. Okay. All right then. So let's go ahead and make a sample disk. Now, if you guys notice on the previous problem, I went ahead and did both graphs. Now for this one, I'm only going to do the first one just to show you that it can be done with just one, but you have to be imaginative, right? So you have to imagine it in your head how it's being rotated. So if you're still not there, if you still need to graph your sample disk, then please go ahead and do so. So graph your sample disk if you need it. In this case, we have here. And actually, before I make my radius, how are these disks being stacked? Are they going to be stacked on the x-axis or the y-axis? Think about it. Think about it. Should I use x or y? The answer is the x-axis. And the reason for that is because our axis of rotation, which is y equal to -2, is going to be parallel to our x-axis. And therefore, because it's parallel to the x-axis, then it must be true that we're using dx. So this is ax dx, okay? Okay. I'm gonna go ahead and draw 2 things and then you guys let me know what it is. Okay, that line that I just drew. Okay, let me answer the question first. Can you explain the work that we have to do with the integral? Oh, of course. So let me go ahead and set it up and then I'll come back to the work for the integral. All right, so here for this problem, the line that I just drew, is that going to be f of x or is that going to be r? Is that going to be f of x or is that going to be r? The line that I just drew. The line that I just drew is f of x because f of x gives you the distance from a point to the x-axis or from the x-axis to the point. So that's f of x. So that means that my r, which is the red line of that point, is this. Okay. This is my R. All right, that's what's being rotated. The R is what's being rotated. Give me R in terms of f of x. Give me R in terms of f of x. All right, the answer to this is f of x plus 2, okay? Now, on the chat, I'm going to answer the two questions that I saw. What happens if you pick a different point? Well, if you pick a different point, notice that it still works. Why? Because let's say that I didn't choose this point, okay? So let's give two examples. Let's say that I didn't choose that point. Let's say that I chose this point. Well, the truth is that this is still f of x, and that this distance is still 2. So it is always 2. This is always 2. It doesn't matter if you do it here and if you do it here. They're all equal to 2. Okay? And the f of x is the only thing that's changing. So f of x changes. All right? Now, there is a particular case that's going to make you think differently, which I'm going to go ahead and try to explain as much to my ability. You have to write it in terms of pi, so you have to go ahead and integrate it. I'll go ahead and show you the integration in a bit. So what happens if you pick, for example, a point that's here? For example, this point, okay? What happens if you pick that point? Well, there's two ways to think about it, okay? So sorry, I used the wrong color. So one of them is to think about it that f of x is negative, all right? So f of x is negative and you're still using 2, okay? So the answer still applies because your answer for that x value, so for example, if you're using f of negative 1.5, you're still gonna be adding 2. Why? Because the answer to f of negative 1.5 is gonna be negative. So that could be something like, for example, negative 0.5, or let's actually go ahead and do it. So the answer to that is 3 over 2. So that's going to be negative 3 over 2 squared plus 2, which, I don't know. Never mind, let's just approximate it. So let's approximate to negative 0.75. And then you do plus 2. Notice that the answer still makes sense. The answer still makes sense, right? Because you went ahead and got something smaller than 2. But if you don't want to go ahead and overthink it, then just make your cylinder or your disc somewhere around here, somewhere in the middle. If you choose something like this, that's going to make you overthink it. So please try to choose somewhere in the middle, but notice that it still applies. You still have f of negative 1.5. And then because negative 1.5 is going to be a negative y, then that's still going to go ahead and give you a smaller answer than 2. Okay, so that's just the different examples that you could have. So now let's go ahead and integrate this. So what is this going to be? Well, this is going to be from negative 2 to 2. And this is going to be pi, negative 2 to 2. Oh, I already put pi. And then you have r squared. So r is f of x plus 2. So f of x is negative x squared plus 2. And then you still have plus 2, close parentheses, square dx. So this is going to go ahead and give you pi negative 2 to 2 negative x squared plus 4 squared dx. Okay. Going ahead and simplifying this is going to give you pi. Let's see, what is that going to be? X to the 4th minus 8x squared plus 4, no, plus 16, because 4 times 4 is 16. Well, let's actually use, and you still have not taken the antiderivative. So let's make this a little bit smaller. You still have the antiderivative and dx. There's going to be pi x to the 5th over 5 minus 8x cubed over 3 plus 16x. Okay. And I believe that you guys can go ahead and do the rest. As you guys know, the rest is just to plug in the values, which is 2 and negative 2. All right. Any questions on this? Any questions on this one? Okay. Let's go back to number 1 and finish it by doing the substitution. How would the rotation look? I'll go ahead and show you the rotation. Okay, so the rotation for this is going to be pretty long. So let's make this 2, 1. That's going to be 0. Negative 1, negative 2, negative 3, negative 4, negative 5. And this is going to be negative 1, negative 2, and negative 3. Positive 1, positive 2, positive 3. We have this one. We have another point here. We have another point here. This is my original. And then we reflect it, right? So we're going to go ahead and reflect this. This is my y equal to negative 2. So if this is our axis of rotation, you always reflect it through the axis. So notice that this is 1, 2, 3, 4. So you're going to go down for 1, 2, 3, and I'm missing 1. So negative 6. And you can do it this way, this way. Okay. And we picked a point somewhere around here. So it could look something like this. So that's a sample disk. And this will be my R. I don't know, it looks pretty good, right? I like it. For a fast sketch, that looks pretty good. I like it. Okay, any questions on this? No? Okay. So going back to number 1, I didn't actually go ahead and give you the answer. So let me go ahead and quickly do it. So this is f of x minus 1. F of x was this. So this is going to be x squared plus 1 minus 1. So my R is equal to just x squared. So that's my R. And we can go ahead and set up my integral, which is going to be from 0 to 2. And it's going to be pi r squared dx. So from 0 to 2, pi r to the 4 dx. So that's going to be r to the 5th power over 5 from 0 to 2. So that's going to be 32 over 5 pi. Okay. So I'll go ahead and post these up on Schoology. Now on your Schoology, let's see, if you go all the way to the bottom, it'll actually go ahead and show you the answers that you have. So here, so it'll show you all the answers, so you have that available to you. However, I do encourage you to go ahead and try it by yourself first. And then I will also be posting in a couple of minutes this one that says answers a 5-volume disc, where I actually go ahead and give you the sketches from your work. However, like I said, I want you to try them first and then look at these. You will not have this on your quiz or unit exams available to you. So please try without them, so that way you get good at them and you won't have to rely on having this.